Hello everyone, welcome back to Add-on to Code 2023. Today is day 11. We're going to dive into that in just a sec. In case you missed it, the day 10 puzzle was split into two videos. I did a part 1 video and a part 2 video. Those should both be in the playlist. If you missed one, you can go back and watch. If you missed like part 2, but you wanted to see how that wound up, go back and watch that, I guess. I did make one tiny change to part 10 in between yesterday and today, which, I start these videos with a review if there is something that changed. I realized that this both odd function I was using is A, only used in one place, so it's not that important to give it a name, and B, there's just a way better definition for it available using uncurry, because now that I just have two bools, I can just say, are they both true? And that's just the AND function. Except that AND takes two arguments and both odd takes a tuple, so you need to call uncurry to get the tuple version of AND. And then you just call that on parse, so there you go. That's all I did since yesterday, or since the end of part 2. So, I have read part 11 and thought some about how I would do part 1, I've read day 11. I've thought some about how I would do part 1. I don't know what part 2 is. And I haven't written any code yet, so you'll see all of that. But to be upfront, I'm not completely blind here as I am on many days. Day 11, Cosmic Expansion. You continue following signs for hot springs and eventually come across an observatory. The elf within turns out to be a researcher studying cosmic expansion using the giant telescope here. He doesn't know anything about the missing machine parts. He's only visiting for the research project. However, he confirms that the hot springs are the next closest area likely to have people. He'll even take you straight there once he's done with today's observation analysis. Maybe you can help him with the analysis to speed things up? The researcher has collected a bunch of data and compiled the data into a single giant image, your puzzle input. The image includes empty space, periods, and galaxies hashes, for example. The researcher is trying to figure out the sum of the lengths of the shortest path between every pair of galaxies. However, there's a catch. The universe expanded in the time it took the light from those galaxies to reach the observatory. Due to something involving gravitational effects, is this So, my recollection is that let's actually, well, whatever. Why not? Let's go back and look at one of the events I did all of, right? 2015. I just look at a random one here. There's this, once you've solved all of them, he adds some underlining to, little jokes that are left in the problem statements. So, by hand, door to door, and the joke here... Oh, you guys can't see the tooltips, can you? There's a tooltip when you mouse over this, which says, this was before the elves unionized, apparently. My recollection is there's one of these little jokes in every problem description, but until you've solved all 50 days, gotten all 50 stars, they're not revealed. So if you knew the secret, you could mouse over it before you did all 50 stars. And I just thought, I don't know, something involving gravitational effects, that's kind of a joke. Maybe that would be today's joke. I don't know. This is just so obviously pseudo-science babble. Techno-babble, that's the word. Anyway, something involving gravitational effects, only some space expands. In fact, the result is that any rows or columns that contain no galaxies should actually be twice as big. In the above example, 3 columns and 2 rows contain no galaxies. Yes. These rows and columns need to be twice as big. The result of cosmic expansion, therefore, looks like this. So we take, this row here and expand it to be these 2 rows here, and so on. And then, equipped with this expanded universe, you just have to find the Manhattan distance between every pair of galaxies and add them up. So, the thought that I had about this was, let's just, instead of building a 2D grid, let's just have a set of coordinates for galaxies. And then you can find out which rows and columns are empty by just like uniquifying the x and y coordinates separately of each galaxy that's in that set. And then, armed with that information, you can figure out the x delta and the y delta between any two galaxies, add how many empty rows or columns are, well, rows and columns are between them, and then like you'll be done. You can just compute the sum. You could also, if you wanted to, actually build this more expanded galaxy from the simple one. And then, like, you know, the distance from here to here would just be like subtract their x coordinates and their y coordinates, right? The problem is, well, that would solve part 1 pretty easily, right? But I was thinking about what could part 2 be that would be on theme and still use this data. Like, I imagine part 2 is going to be actually space expands in some different way. And I'm not so sure that my like sparse, my notion of just get the coordinates for galaxies and then count how many rows and columns are between them, I don't know if that's necessarily gonna like be adaptable super easy to part 2. Because maybe part 2 is like every empty space that's surrounded only by empty space is actually bigger. But I don't even know how like that would work. How you... So I don't know. I guess what I'm getting at is I don't actually know what... There's no obvious part 2 for me that I need to plan around. So I guess I'll just implement part 1 in the way that I just described that makes sense to me. Okay. So we need a strict map, I think. And we want sets as well. We need a coord is a coord of y and x, which are both ints, just like yesterday. I mean, we really ought to say data feature again. Like, obviously, we could just use like a bool for whether it's empty or has a galaxy, but you know, Haskell encourages you to use data types to model your domain and not just rely on the built-ins because they happen to be isomorphic to your domain. So let's say a feature is either empty or a galaxy. Although, wait a minute. Well, okay. This is going to be like a... Actually, am I ever even going to use this type? If all I have is a set of points at the end, this would only be needed for an intermediate type, and frankly, I don't know what I would need it for, so forget it. I'm not going to have any bools, right, because I'm not building the grid. Right. So let's, I guess, define our input type, which is going to be a set of coordinate, basically, right? And we can write our parser, which should be straightforward. Is this... So how do you... Obviously, I can compose a function with lines, and like I can loop over the lines and loop over the rows in the lines by zipping. Do I want like... I guess I want a map maybe over... Like, okay, so... Prepare of text, I don't know, is... We could say for... Well... s.from list... Oh, yeah, this is what I should do, I think. S.from list of do. This makes sense to me now. Let's let y row come from zip 0 with lines text. X character come from zip 0 with row. And then case C of, if there's a hash, then we say pure, we're gonna return something, and that's yx. Actually, I guess it's coord of yx. If it's a dot, we do nothing. There's probably a better... I could write empty or mempty. They're all going to be an empty list, so it's like fine. And anything else, we say error, unexpected, pure x. Okay, that all type checks. Okay, given that it compiles though, let's make sure it actually runs, which I guess I need to get my input first. And then I can let's just return the input for now. Oops, well, sure, that can be part 2, I guess. What am I doing? I forgot how to switch windows. Here we go. So if I say stack run here, it should print me some number of variables, or of positions for, sure. You know, is this the right list? Probably. We could do a quick spot check and confirm there's a galaxy at 030, I guess. Yeah, and that it's the first one. All right, that seems fine to me. Looks like it worked. It points out that I... Wait, what are you mad about here? Oh, X shadows the existing binding. Sure, we'll call it C. Well, we already have C as well. How about that? We'll reuse the existing C. Fine. And, I mean, it's upset that I'm not using data map strict, but we'll get there. Wait, will we? What do I need a map for? I have a set of the galaxies. I'm going to have a set of the empty rows and a set of the empty columns. I don't see what I need a map for. Yeah, okay, sure. I don't know what I thought I was using a map for. I guess because I was imagining, like, coordinates mapping to some information about that coordinate. But here the information is just, like, nothing. It's just, like, you have to know there's a galaxy there, and that can be implied. So we could have a map from coordinate to unit. Store no information in the map, but let's just use a set instead, which is, of course, what I'm actually doing here. Okay, sure. Um, so I think what would be nice is next to write a function that takes a set of coordinates and returns two sets of ints. Those being the one set being the rows that have galaxies and one being the columns that have galaxies. Now I could, of course, produce a set of columns that don't have galaxies, but that's quite a bit harder and not really that much more useful, because you have to like get the bounds right and stuff. Whereas if I just like look at every galaxy and say, okay, sure, you know, I'll use this number and I'll put it into the set of rows that have galaxies, right? So, and we'll just have to do a tiny bit more extra arithmetic to get galaxies without, or rows without galaxies from rows with galaxies. So let's what do you call such a function? Occupation status? Oh, census. There's a good one. Census. Good. Do I want to type for this? Maybe just a type alias. Except this still isn't going to tell me. It's not going to help that much, right? Because I'll just say it's a list. It's a pair of two sets of ints, or set of int, right? But this doesn't tell me which one's left and which one's right, or which one's x and which one's y. Well, we'll say it mirrors coordinate, and that'll be our mnemonic, and it'll be fine. So since I don't know why I keep wanting to put an R here, by the way. I guess because when I type SU, like 1,000% of the time, I'm typing sure. But no, sometimes I type some. I don't have any trouble with that. So why I don't type censure very often. I don't know. Census is a function from set of coord to census. Census is just a fold map. Go? I don't know. I think that's basically it. Where fold map, where go of coord yx is singleton y. I can't say pure, right? Because a set isn't duplicative, I believe. I mean, it couldn't be, right? Do I have data set open somewhere? Not really. I think I remember asking this question on an earlier day, and then I realized like you can't do it. Or I was confused about there wasn't an instance for something in set that I sort of thought there might be. And I think I must have assumed there was applicative, but there isn't. And that makes sense, I think. Yeah, so the function for like making a set containing one element, you should just use singleton. For some types, like pure is like a list, for example, is a good way to take an A and turn it into an f of A for whatever f you're talking about, but for lists that doesn't exist. So singleton x, and I think this is it. Yeah. So this looks a little bit maybe magical. Where like So what this is doing, of course, its type tells us what it's. Well, okay, the type is vague enough; it could do anything. But we're taking a set of coordinates that have galaxies and producing a census, which is a set of y's that have galaxies and a set of x's that have galaxies. How is it that fold map knows that's what we want, I guess is the question. Like, yeah, sure, we're returning a census, which is a tuple. But most folds, right, you know, we've looked at... What are some recent folds we used? I don't know, like fold R is an example, right? You have to tell it the accumulator type. Because you have to give it an initial accumulator and a function for combining two accumulators. And here, somehow, I'm just telling it, like, you know, for every coordinate, here's a tuple. You figure it out. And somehow it knows that what we want is to create, from the left elements of each tuple, a set that is the union of all those lefts, or I guess we would say firsts. And from the second element of each tuple, create a set that's the union of all those seconds. Like, how on earth have we given this information to FoldMap and said that's what we want? And the answer is, like, type classes! It's magic! But more specifically, a census is a tuple of two things, two sets of ints. And if we go and we ask, tell me about tuples, please. You see there's a bunch of stuff, but I want to draw your attention to, specifically, monoid instance, which of course also implies a semigroup instance. If we ask about monoid, what are the operations of a monoid? Well, a monoid has an empty element, an element that has no it has a monoid is three things, right? It's a set of elements that it works on, and a combining element, or a combining function, mappend, which takes two elements in the set and produces another. And it has mempty, an element that is neutral to the appending function, where, like, x appended to mempty is just x, and mempty appended to x is also x. So, like, if either of these two elements is mempty, then the result is just the other element. So it's those three things, plus the law that... Well, first of all, the law I just said about how mempty and mappend work together, but also the law that the mappend association operation should be associative. So, like, it shouldn't matter how you group combining operations. Ordering them might make a difference, but grouping them shouldn't make a difference. So, like, we can say that for any lawful monoid, A and B with C is exactly the same thing as A combined... Is this right? Yeah. And here, this is just an inline name for mappend. So this is the important feature of monoid, is that the way you group these operations doesn't matter. And that there's an empty element. And sets are monoids. Mempty is an empty set, and mappend is just like union the sets. If we were to look at the source for data set, in fact, I mean, I can do that. Why not? I assume we would find, yeah, mappend is unit because this is an old enough file that like it predates this getting it. But yeah, it just says this getting this operator didn't really used to exist because semigroup didn't exist, and mappend was the like canonical definition in monoid. These days, monoid's mappend is kind of vestigial, and you should use the semigroup instance, but mappend is still exists. Anyway, the point is, mempty is an empty set, and to combine two sets, you union them, right? That's what I predicted it would say. So, sets are monoids. That's what a monoid is. Why is that important? Well, because if we look at the type of fold map, we'll see that fold map says, if you give me a T of A, where A is anything that's listish, anything you can like iterate over, and a function from A to M, where M is any monoid, I'll just give you back one M, the result of combining all the results of calling your mapping function on all the items in the foldable. So it starts with mempty, and then it calls like your function, and it mappends that into the accumulator, and it looks at the next item in the foldable, and it mappends that in, or calls your map function, it mappends that in, and so on. So that's what fold map does. And we're now almost at understanding why census just works without us saying how to combine things. So if we were just building one set, that would make sense, right? If I just wanted, like this will type check as well. Except that census is the wrong type now. There you go. So now it said, okay, sure, there's a type error because you haven't like said what type it is. But if it's inferred the right type, set event, and this is a valid function, we would say, you know, please run this function go over all the things, and go will say, give me a set containing just the y elements. Fold map will combine them, and we'll get one big set containing all the y elements. But how is it that when I give it two things, it just knows, oh yeah, of course, he wants to combine the lefts with the lefts and the rights with the rights. And that's because, as I mentioned, if we look at tuples are, where is it? Yes. A tuple is a monoid if its left and its right are each also monoids. And given this this instance signature, it's basically impossible to write anything but a reasonable monoid instance. Technically, you could do something silly. Well, could you? I was going to say, so like, if we were going to write the monoid instance for sets, for tuples, it would look like this. Instance, actually, let me go copy paste what's the instance head that's already there. Where we would say like mempty equals the tuple mempty, and mappend is mappend of a b or a1 b1 and a2 b2 is a1 a2 and b1 b2. So this is like, this is the definition that you will find if you look in the tuple source, and we'll do that in a minute. It'll be a little bit different because it won't use maybe it'll look exactly like this. I don't know. Maybe it'll use the semigroup instance. But the point is, it kind of has to look exactly like this. And I was in the middle of claiming that this is the only possible thing you could write that would like type check. That's certainly not true, because you could write like, you know, oh, it's just B1. We'll just ignore the second element completely. That type checks, So and you could also say, oh, I'll use B1 twice, and then B2. That also type checks and is stupid. I don't think this would be lawful. I don't think the other one would be lawful either. Because then mempty wouldn't be both the left and right identity, would it? I'm not sure. Anyway, the point is, this is about what the definition will have to look like. And if we indeed go look at... how do I even... I guess I want to look up monoid and then go find the source of that. Monoid, yeah, but I want to find like the type of tuples. Okay, so go look up. It's just not there, huh? I don't actually know where to find the definition for tuples. Maybe it is in monoid. If I, yeah, monoid. There's a lot of monoid instances in base, but eventually we'll get to, here we are. Take me to the source for this. Yeah. So it says, okay, for monoids, mempty, and the semi-group is where the app instance is. Why is this for A, B, C? Where's A, B? Oh, it must be higher. I see. So A, B combined with A prime, B prime is A combined with A, and B combined with B. Why do they define S times? Is this more efficient than the default would be? I guess so. It saves some packing and unpacking of tuples. Okay, but it's not mandatory. S times is just a function that you can get for free, but if you know a more efficient way to implement it for your monoid, you can do that. So the point is to combine as a monoid a pair of two things. You just combine the things pointwise, the left thing and the right thing. So type inference and type class magic is what gets us this very simple, way to derive two pieces of monoid information from our coordinate. Isn't that nice? So a long digression there where we weren't working on advent of code. But I feel like a lot of people who watch these videos aren't really looking for, like, I gotta find the solution to the advent of code video problem as fast as possible. You are watching the wrong channel for that, let me tell you. And there are people who say, wow, I just learned so much about Haskell watching your videos. And so, I don't know. I try to educate on this stuff like this where I can. So, that's our census function. And so I think, like, part one, we kind of want to start on that now, right? Part one of G, the galaxy. Well, no, G, it's the universe, right? The universe has many galaxies in it. The U is our set of coordinates, of course, is some map. I think I'm going to want to uncurry distance in a way. Yeah, I guess that's okay. I'll explain what we're doing once I finish writing this. Uncurry distance. Cartesian product what is that called in sets? I know it's Cartesian something, but I don't have the set documentation open. Data set, please. Cartesian. Okay, it's just called Cartesian product. So we're going to take a product, a Cartesian product. Maybe do it like this. Union the galaxy with itself. Oh, I didn't qualify S. So we're going to take a Cartesian product of the universe with itself, and that'll give me a list of pairs, or a set of pairs? A set of pairs. Well, that's a little bit annoying, because I want a list so that I can compute a value for each of them and add them up. What are other functions that I can use on sets? I want a fold, I guess. Map I don't really want. Map is definitely bad. Foldar, I mean, does it have fold map? It must. Is that what I want? Sort of. I mean, a set is foldable, but is that interesting? I can just call toList on it if I want to. Right, I can say toList, but any other cool instances maybe? It's foldable. I don't know what list is, or lift rather. Yeah, okay. Well, I guess I'll just call toList. I could fold map over it and like get a monoid out, but what I want is just an int. And ints don't have a monoid instance. Not because they couldn't, but because they could have two. Right? There are two different operations on int that are that have an identity element which can act as mempty and an operation. Right? You can either add them and 0 is the identity, or you can multiply them and 1 is the identity. And so int doesn't have a monoid instance. Neither of those is preferred as the default. Instead, there's a new type wrapper you can use if you want to view an int as a sum or view an int as a product. So, like, we could say fold map distance. I guess it's fine. We'll do it. From data monoid, I just want sum, please. I want to view my ints as sums. So we will not call sum, we'll call get sum. Fold map uncurry distance. I mean, we don't even have to call get sum technically. We could just have our output be a sum int instead of an int, I suppose. But I don't want to. So we'll take a Cartesian product of the galaxies. So we have every pair. Then for each one, we'll compute the distance for that pair. And then that'll give us a sum, and we'll just call get sum. So we have to write the distance function, obviously, where distance of coord y1 x1 coord y2 x2 is I think fairly simple, right? It's just abs of y1 minus y2 and plus abs of x1 minus x2 plus x expansion, I guess. And then plus y expansion, where we still have to define those. Well, here's a funny thing. Why don't I write mconcat here? Fold map sum. And so instead of plus, I'll just use the monoid machinery. This is not like better in some fancy, cool way, but it does let me like say, here's a list. There are 4 separate components. We're just going to add them all together and combine to a sum at the same time, which I guess is okay. X expansion and Y expansion, where X expansion is, we're gonna have to, it's basically like, I mean, rows between oh, how about empty rows between, oh, getting to use a function as an infix, how nice. Max x1, x2, and max or min x1, x2. And y expansion is something very similar. Empty calls between max y1, y2, and min y1, y2. Now we still have some more things to write. We have to write between empty rows and empty calls, but we're getting there. You know what? I think I'm gonna indent this further to the left, please. And then maybe I'll just do this. We have to write empty rows and empty calls. And then we need this between function that is fairly simple. Well, annoyingly, empty calls, empty rows. We aren't, our census is going to tell us populated rows and populated columns. So maybe what I'll do is between will be a function that takes a census and a function to say which half of the census to look into, and 2 numbers, and says to you how many things are empty between those based on the census, I guess. So then I really just need to write between, and also, of course, actually get the census. I guess I can just say C is census of U? Is that right? Where's my census function? It's down here. What the hell? Oh, I put it after before prepare. I can see why I would have done that, but that's not what I want. And between between of f dimension. Okay, dimension. High and low is, so it's high minus low. Not really, right? I mean, is that... It's high minus low minus the number of empty spaces in between high and low, right? But minus the number of populated spaces. Could I say, though, that it's the number of populated spaces in high minus the number of populated spaces in low? No, that doesn't make sense because populated spaces takes a range. Could I say it's the number of populated spaces between 0 and high minus the number of populated spaces between 0 and low? That would give me the number of populated spaces in between high and low, because the ones below low would cancel out. And then I could subtract that from the total high minus low. I think that's the best I can do. Is high minus low minus unpop of high minus unpop of low. Where unpop is implicitly comparing from 0 to high and 0 to low. Okay. Unpop needs to be in its own little inner where clause because it's depending on dim, of course. Of n is, and now we have to go read the docs for data set. It has the function I need, but I don't remember what it's called. It's not min and max. I want to split it. Is it filter? Take while, span, split. Here we go. Elements less than x and elements greater than x. And we don't really care what it does with x, because it should all we know x will be in the set in both sets, and so it'll just cancel out, I think. So I think I want to say split the set at is let below, and I don't care about above, equal split at n, right? So that'll give me the set of populated things below x, strictly below x. And if I subtract that from x, I almost have the right number, right? I think it's off by 1 somewhere in... n minus size of below. I don't need this parenthesis. So would this be correct if I had a galaxy where there was something in row 1 and I was asking how many are unpopulated? Let's say, let's improve this name to unpop below, shall we? So it's clear that it's not referring to a specific column or whatever. It's specifically the range below it. So if I had a galaxy where the first row was empty, and I said, what is unpop of 1? Asking how many unpopulated rows are there below 1? The answer should be 1. Is that what I would get here? I would split at 1, and below would be empty, right? Because there's nothing in the set below 1. I would say n, which is 1, minus the size of below, which is 0. It would be 1. So I think that's right. So this seems okay. Is there some function, actually, like, it occurs to me now, that takes, like, 2 ORed things and gives you back the min and the max of them? That would be kind of cool, wouldn't it? I guess I would say ORed A. I have an A and a B, and I want back a pair of A and B? No, I have 2 A's, excuse me. 2 A's, and I want back a pair of A. Does this exist? It's not looking good. This div mod, yes, very funny. And what if I took a pair of A's as input? Sort pair. Yeah, swap, of course, very funny. So I don't think so, unless we wanted... What the hell is data tuple HT? Sure. Yeah, so it's convenient for quick hacks, but I agree it's bad. What is HT? Various small helper functions for lists, maybes, tuples, and functions. Yeah. I used to be a bigger fan of your own personal utility library than I am now. Who wrote this? Henning Thielemann. Okay, I've never heard of this person, but their initials are the package in the package name, so I assume it is this person's own personal utility library. 100 direct reverse dependencies. Okay, interesting. Okay, so there isn't such a function. I was just thinking it would be kind of nice if instead of writing max like this, you know, twice, if I could just say, give me the min and max of x1 and y1, and I'll use those. But, okay, I don't know. It isn't. So, does this compile? No. Between is applied to the wrong number of arguments. Why? That looks right. It has 3 arguments. Is that allowed? Can I? No, this is an invalid way to define a function, apparently. So maybe the problem is that I don't know how to use infix notation. I'll write it this way then. Couldn't match. Oh, I didn't give an argument to s.split. Oh, maybe that's why it was upset. There's a type error in unpop below that rippled all the way up here. I bet that's true. If I say that I want unpop below to be a function from int to int, there will be a type error in unpop below. No? That's so weird. What should the type of between be? Between is a function from census to int. That's not how you spell census. And two ints, returning an int. I'm like baffled. Why? Oh, wait. Not census to int, but census to set of int. Set of coord, in fact. Wait. No. Set of int. Set of int. Set of int. Is that really the only type error, or is it confused about... Oh, man. It's confused about so many things. What have I done wrong? I don't believe this probable cause. Something else is wrong at a deeper level. First argument of max. Oh no, what? Why does it expect one of these to be a function? It expects x1 to be a function of two ints. Or a function from int to int. Why? Oh, I didn't use dim at all. That's the problem. Between depends on dim, but I'm not using it. So let's let... yeah, I didn't use this here either. S is dim C. Split n S. Wait a minute, split. I guess that's fine, actually. Yeah, of course. Split. I just briefly looked over the type of split, and I was like, wait, it takes an A, not an int? But our A's are ints, and of course a set would take, like, you know, a set element and not an index to split at. Okay, I don't know why this briefly threw me off. Okay. So, did this fix any of our type errors? Okay, now we're getting somewhere. I called dumb. Oh my god, I'm describing myself involuntarily. It's a Freudian slip. Now I'm dim as well. Oh no. Okay. I still have a million type errors. It still thinks x1 should be a function of 2 ints. Why do you think this? Okay, I really need to just put more type signatures on stuff, I guess. But what can I even, I mean, S is a set of int. Yeah, of course, that's all the same. Unpop below, I mean, this has these, hello? I've put type signatures on everything relevant. Oh, you know what? I bet the problem is maybe distance doesn't have the right type and everything else is getting inferred from that. Distance is a function, I think, from it takes 2 coordinates and produces a sum of int. What? So all of this is none of this is making any difference. Clarifying what types I think things have, it says, yeah, you're totally right. That's what type I thought they had, but also all the types of your terms are completely fucking wrong. You're upset that Max is getting an int. You thought it should get... How could max of a function from int to int even make sense? Functions can't be ORed. But I guess it doesn't get that far. It just says, oh, I proved this has to be function from int to int. The fact that that's impossible does not bother it. Well... Like, look at this. It's saying both elements of the max pair, of the y pair, should have been functions from int to int, but actually they were just ints. It's like, obviously they were just ints, you idiot. Why did you think they're supposed to be a function from int to int? Okay, well, here's something. What if I start telling you what types I think these terms have? This is an int. How do you like them apples? Okay, now it's... What? Am I confused? I'm probably confused about infix functions. Oh, this is what's wrong. So, okay. This time it is because I'm using an infix function wrong. I always get confused when I try to use infix functions with more than one argument. Or more than 2 arguments. Because I think, like, look, if you write FAB and, you know, GCD like this, the operator that is splitting these two is this. And it's like, it's the left half, FAB, is one expression. GCD is another, and then this M-append combines them, right? And so I think if you write FAB, you know, M-append, GCD, that it should be the same thing. FAB is a sub-expression and GCD is a sub-expression, and then you M-append the results. But I think that's not what it means. This actually is... You get like this. FAB, M-appended to G, is a function. Now apply that to C and D. Okay, fine. Well, telling it that I expected the int here was exactly what I needed to do to get it to tell me what I was doing wrong. It had said, oh, you must have wanted this to be a function because you're calling... So, like, okay. You're passing it as an argument to second between. Right? Now it type checks. Okay. So let's get rid of these stupid types that are not actually very interesting. And, I mean, it's possible this is just right. Should we find out? Oh. Part 2 is still outputting a big pile of garbage, so I couldn't read the result. That is a very large number. But I guess there are an awful lot of galaxies out there, huh? And we're squaring the number of them and then multiplying it by, I don't know, on average 40 or something for the distance between them. That seems fine. This is plausible, I think. I was just thinking the distances are not all that large. How could it add up to such a big number? But the answer is we're adding together a lot of smallish numbers. Too high. Okay, fine. Oh, right. Here's something I thought of but forgot to do. So, it is funny how just like you immediately think of what's wrong when it tells you your answer is wrong. Like, why didn't you just start by thinking, is my answer going to be right? And then like think of what the problem is. Why, like, it's just so pleasant to assume things are going to be okay. You don't want to think about what could go wrong. And then when something does go wrong, you're like, oh no, what could have gone wrong? It's like, oh yeah, this. It's harder to start with like, what could go wrong in the future? Nothing. My code is perfect because I'm a genius. Oh, it's wrong? Oh, it's because I'm a fucking idiot. This is what I did wrong. Okay. So the problem is we got the Cartesian product of the galaxies. And one thing I didn't mention, but I did have planned, was, well, wait a minute. The Cartesian product isn't quite what we want, right? We have galaxies tracing the distance to themselves. Because Cartesian product is all, you know, it's all pairs of galaxies from the input. And that means galaxies can be paired with themselves. Well, so that's fine because the distance from a galaxy from itself to itself is 0. So adding that in is harmless. It does cost us a little bit of compute time, but not an amount that matters. However, there is a problem here, which is that we're computing the distance from each galaxy to from galaxy A to B and from galaxy B to A. So, like, we could trim down the Cartesian product to only those pairs where the left is bigger than the right, for example. Where bigger is just whatever ordering coordinates naturally have. I don't really care. I just need to have each pair present only once. And I don't care what the order instance is. As long as it is some ordering, I'm happy with it. However, it's much, much simpler to do twice as much work and then divide by 2. So let's see if that's any better. And then maybe we can refactor it to... by the way, it was even, so good evidence that that was part of the problem. If this is right, maybe we can refactor to like doing it the cleaner way, but this certainly is simpler to test if that was the only problem remaining. This is still too high. Okay. I have fewer good ideas now. I mean, some of these functions in part 1 certainly could use some testing. It's not totally clear what the best way to test them is. I mean, we could grab our test input and test against that. But I assume we would just get the wrong number, so I don't know. It's a little hard to extract pieces of part 1 into global top-level functions. Well, one thing, let's just reorder these so we have first and y before second and x, just for symmetry. So between dim, high, low, we want to compute the unpopulated areas between high and low using dim as our reference into the census. You know, this would be simpler if I didn't... if I just passed C, right? Here, and I said first of C, second of C, S. Oh, I was calling this S, sure. No? Unpop below. Oh, this one was supposed to be C. I somehow put an S there. I assume this should still give me the same answer, right? I'll run it just in case, but yeah. Okay. Why did I call this S? I don't know. It doesn't really matter. We're only looking at y's and then x's. That's fine. High minus low. That's the distance between them. Which could be 0 if they're the same. Would be 1 if they were offset by 1. Unpop below of high. Minus unpop below of low. That should be the number of unpopulated... Wait a minute. Why am I subtracting... Why am I running high minus low minus something anyway? All I want is the unpopulated things in between high and low. Shouldn't it just be this? The number of unpopulated things below high minus the number of unpopulated things below low. That's the number of unpopulated things between them. I think I must have started writing unpop below with the idea that it would be giving me like populated things. But I still don't think subtracting high and low was the right idea ever. Okay, so that I think is a fix. Is it the only problem? Let's not run the program again yet. Unpop below of n splits the set of populated galaxies at n, or populated places where galaxies are, splits it at n in the dimension we're looking at. I ignore the ones equal or greater, and I get just the ones below. I think this is right. Because n is exactly how many since n is like 0 indexed as well, n represents exactly how many rows or columns could possibly be below n. It's how many are below n. And if we look that, and if the number that were in the set of populated things, we subtract that number, and we get how many could have been there but weren't, which is how many are unpopulated. So I think that makes sense. Let's stack run this and hope to goodness it gives me a lower number. 7 digits instead of 8. I'm happy. Okay, that's the right answer. So, I don't know. This is a little bit of a lesson of sorts in, okay, A, the importance of doing your arithmetic right, but, like, just because it type checks doesn't mean it works. The reason that Haskell has such a reputation, like, which you can spin positively or negatively, right? But, when you're working with fairly abstract data types, you have type variables and type classes, there's often not that many ways to fit together the types into something that has the expected output type. And so if you can get it to type check, like, you're fairly likely to have found, you know, one of the ways that's correct. Sometimes there's literally only one way to combine some types and get the result type. Like, for example, a classic is like, you know, first is a function from a, b to a. How many ways can you implement this function? One. There's only one function that has the type that has this type, and it's the function named first. There are ways you can like spell the implementation differently, but they all behave the same. So if it type checks, it's right. There's really no question there. But like a function from 2 ints to ints, like you are at sea, man. You better get your math right because there's a million things that would type check. Way more than a million, of course. So when you're doing stuff like with a bunch of ints, you have to be really careful because Haskell can't save you as much. It would be nice, you know, where sometimes you can like add a new type in to like make sure, oh, this is degrees Celsius and this is meters. And you can't accidentally mix them up and Haskell will help you there. But if you just like have two things that both represent, you know, a distance or something and you add them, but you should have subtracted them, it can't really help. Here we were, you know, we had like 2 quantities and we subtracted them and that was fine. But then we had 2 other quantities we subtracted and we subtracted like, you know, for no reason. How is Haskell supposed to know? I don't know. You just got to think through the math and be careful. So git add p. I think I'm just committing all of this, right? What's wrong? Button. Yeah, I don't think there's any part of this that I hate. Day 11, part 1. All right, let's see what's going on in part 2. The galaxies are much older and much further apart than the researcher initially estimated. Oh, each empty row or column is 1 million times larger. Okay, great. That's the easiest thing in the world. We're already not iterating over things. So we just have to, like, extract this entire thing out. To a function called solve, which takes an int and produces a function from input to int. Solve of factor equals this. Right? Or don't I need a... I still need a u. Solve factor and u is... factor times this. So just how much space is expanding. We'll just throw one factor in on that between function. And that's it. So part 1 is solve 1. Part 2 is solve 1 million. And like we're done. Stack, run, I'm happy. I am reasonably confident this will produce the correct answer. Did it produce the same answer for part 1? That's the important thing. It did. Okay, so let's just punch this number in. It's very large. It should fit in an int64 still, though, right? There wasn't any overflow around here. Just before I type this in, let's oh yeah, that's way, way, way bigger than our number. Okay, great. I mean, I guess it still could have wrapped around, but I don't think it did. I think Eric tries to give you things that'll fit in a 64-bit int. Unless he has a very good reason not to. It's too high! How dare you. Okay. Oh, you know, wait. I guess... the issue is that instead of doubling them, make them each Like, instead of replacing them with 2 empty rows, you replace them with 1,000,000 empty rows, right? But I pass 1 in to do part 1, not 2, even though we're doubling the width and height of all empty space. So I think, like, factor is not quite correct, or, like, there's an off by 1 error in how we handle factor, basically. So let's... What? Because really, I should be saying solve 2. We're going to make all empty space twice as big. Kind of, right? And then we multiply by factor minus 1, because we're already counting walking into the empty space once in the absolute value of their distances. And then we need to count it 999,999 more times, because this space is 1,000,000 times bigger. So I think actually we should write solve 2 here and multiply factor minus 1 by this. And this is a bigger or smaller number? It is smaller, which I think is what we were supposed to do. I've already forgotten. I think our number was too big. Let's try this one. That's the right answer. Okay, we did it. So part 2, not a huge challenge, but definitely I did mess it up a little bit. I talked a big game about being absolutely certain my answer would be right, and, like, wouldn't you know it, there was an off by 1 error. Shocker. Programmer has hubris, more at 11. Yeah, I mean, overall, though, seems good. I really should, like, take this out of my template. I don't use these nearly as often as I thought I would when I wrote the template. Oh, well. Got confused between git and add, wrote gid. Yeah, I guess we just write day 11 part 2, no problem. I don't do the git pushes on camera. Not that I'm leaking anything, unless you can listen to me type my SSH password and figure out what it is, you know. But just not that interesting to show. There you go. So that was... Is there anything that I need to cover here more that I didn't already? I don't think so. This math was, like, kind of the whole problem. In addition to thinking about, like, I don't know. The most interesting was talking about how monoids and fold map work, I guess, today. Parsing was pretty simple. Yeah, okay. Hope you guys enjoyed. Thanks for watching, and I'll see you next time.